Yeah, as Chandrayaan is a success, so all our participants are also eagerly waiting over there. So another 2-3 minutes we will wait. Let people should join. I think as of now, Pratik, Mamta, Supriya, they have joined. So we'll wait for another 2-3 minutes as uh, Chandrayaan 3 success is there. So we'll wait for again 2-3 minutes again more. Yeah, I think Dr. Shiva Prasad sir has joined. Welcome, sir.
Yes, sir. Good evening, sir. Welcome.
Yeah, yeah. Good evening. Actually, it's a
Thank you,
great
sir.
achievement
Yes, sir.
is
Yes,
there.
sir.
So,
Yes,
how
sir.
much happy we are, and
Yes,
your
sir.
talk
Yes,
is
sir.
there on this.
Yes, sir.
We
Yes,
are
sir. Yes, sir. I'm
actually,
so happy we achieved. Yes, sir.
yeah, yeah, extremely happy.
Happy. Yes, sir. Yes, sir. Yes, sir. All credit goes to the whole world and those who worked beyond this success. Yes. Thank you. Thank you. Thanks a lot, sir. Thanks for giving your time. So that we
Yeah,
will go to session now.
yeah.
I will move on to the session now, sir. One minute. Let me join and I let me share my screen, sir, so that I
Okay.
will we will have a discussion regarding our topic, sir.
Yeah, yeah, sir. Yes, sir. Definitely, sir. Sir, definitely.
Sure, sir. Thank you. Thank you, sir. Yes, sir.
Yeah. So formally, I welcome to Dr. P. Shiva Prasad, sir. Uh, so I am very happy to welcome you on this occasion. Everyone is happy. Uh, yeah, on to Sai.
Yes,
Uh,
sir. So,
Sai.
welcome to all the participants. Our today's speaker is Dr. P. Shiv Prakash, sir, who is currently working at iNurture Education Solution Private Limited, Bangalore. And sir is going to deep dive into the concepts of AI, ML, and Internet of Things. So, sir, I request you to please take over the session.
Yeah, go ahead, sir.
Thank you, madam. Thank you. Thank you. Thank you, madam. Is there whether my screen is visible to you all, sir? One minute, sir. One minute.
Yes, your
I will
screen is
share
visible
my
to
whole
yeah,
entire screen
visible.
so that it will be visible.
Yeah, it's visible.
One minute, sir. One minute. இங்க வச்சிருங்க. இங்க உள்ளேயே வச்சு நீங்க சாப்பிடுங்க எடுத்து. ஏன்னா ஸ்டூடெண்ட்ஸ் எல்லாம் உள்ள இருக்காங்க. Sir, I am facing some internet issues. 1 minute, sir. 1 minute. I will be back. I'm here.
Yes, sir.
Yeah.
Sir, till then, should I just post some questions in the chat box as a quiz?
Yeah. Go ahead.
Sure, madam. Sure. I will give you some. Shall I share you, madam? I need to share
Yeah. Once you're
because.
ready, you can share.
Okay, let
Meantime,
me.
some questions will go. Yeah. Go ahead. Go
Sure.
ahead.
Okay.
So yes, participants, let's do a short quiz. I will be posting some questions in the chat box, and I'll give you 1 minute of time. And make sure you answer in the chat box. We will just begin. This will just brush up our concepts that we have already studied in our previous sessions before we dive into today's session, right? So yes, I've posted our first question in here. The question is, what is the main advantage of using AI for predictive analysis in IoT systems? And the options are improved hardware performance, reduced data collection frequency, real-time data processing, and the anticipation of future events. Yes, we have one answer from Pratik. Any other answers? Okay, Vijay also says C. Any other answers? I'll wait for more 20 seconds.
Yeah, I am back, ma'am. Shall I?
Yeah. Sir is back.
Yes. Okay, so
Yeah.
sir is back. We will continue the quiz
Yeah.
session
Yeah.
later.
Yeah. Yeah.
So please continue.
Sorry for the interruption.
Yeah.
Yes,
It's
madam.
okay,
Thank you.
sir. Go
Thank you,
ahead,
madam.
sir.
Sorry for the
Yeah.
interruption, sir.
Yeah.
Yes, sir. Here that we are going to learn about what are all the topics that in the machine learning, what is machine learning and supervised and unsupervised learning in the IoT applications that we are going to see today as a today's session. That here we are giving a machine learning which plays a major role over here as we have learned yesterday that we have gone through the deep learning. Before that, while we are going for deep learning, before that we need to know about supervised and unsupervised learning in the machine learning. So why we are using and what are the types and what are the algorithms that we are using for machine learning and how it is directly which is connected to IoT application. So this should be that we need to concentrate on this. Okay. Over here that the objectives here understand about the machine learning and evaluating the importance of machine learning and then different types of machine learning and machine learning in IoT applications that we are going to see in the today's session. Okay. Uh, Here, this is the outcome where we are going to understand about the machine learning definitions and we are going to see the different techniques and algorithms of machine learning as an analyzed or practical approach that I will show you how the data can be clustered and how we can get the output from that tool. Okay, and I would like to show you machine learning environment based platforms where Anaconda and Jupyter, etc. Over here, that there will be the table of contents. Here, these are all the contents that we are going to see today session. That which is IoT and what is machine learning, applications of machine learning, and types of ML, supervised machine learning, unsupervised, and then semi-supervised, where there will be the overfitting and the underfitting problem is occurred. So meanwhile, that in during that time, how we are managing that overfitting and the underfitting problems. that we are going to see in the today's session. Okay, here. So before that, we are going into the topic that we need to know what is IoT. So Internet of Things. Without with Internet that we can do n number of works that humans cannot do. Like without intervention of humans, that the work will can be configured and it can be done by the uh, computer or a machine where it produces the output with the accuracy. Okay. Over here, that IoT plays a major role nowadays. That we are in an era, in an internet era where we are having n number of devices which is connected with the internet. So each and every devices which is connected in the internet, which gives an like what to say, like the data, it will produce a data. So those data can be processed in such a way that we are going to get some outcome. So whatever the data that we are getting from the IoT, one from the device, so we are going to process those data. So that is the major thing that we are going to do. Okay, for that reason that we are having supervised and unsupervised learning. Okay, so over here we are having like we know that we are having a number of devices. Like for example, that we are having a smartwatch. In future, that I would like to show you one example. Like we are having that we are going to have one IP address for each home. For every home, that they will give one IP address, one IP address. So with the help of that IP address, that which is connected with all the devices, like we are in a remote area, that we can access and we can do some things with the help of that IP address, and then which is connected to the internet, so that we can monitor, or we can I think we know that the data that we are fetching from the IoT devices. As you know, as we know that we are having in future that they are planning to give for example, that there will be the refrigerator. The refrigerator will have an IP address over there. In that refrigerator, there will be the internet will be connected through that. So each and every places there will be some what to say, like box of places will be there, that where we are placing the items over inside the refrigerator. So for example, like we are going to use eggs we are going to store our eggs in the refrigerator, so that whenever that we are using that eggs, so that the sensor will be placed and which is connected to the IoT. So nearby market, nearby supermarket, that they will monitor whatever that we are having in the fridge. So automatically, if our items are very less, or it is going to be like if we need that, automatically the supermarket team will come to our house and our home, and then they will deliver whatever the products that which we need. So this is not by the way of that we are communicating with the supermarket. It is automatically, it will be happened with the help of sensor which is placed inside the refrigerator, where all the data can be fetched by the sensor, and then it will connect to the IoT devices, and it will give the results to the person who we need, the uh, person who we need to help. So these kind of things can be in this kind of things can be done in future as well, that we are expecting over that. And here there will be the short about the internet. IoT, Internet of Things, where here interrelated computing devices, which means that the computing devices which do some operations and it will produce the result, where that should be like that should, with the help of that, there we are getting some outcome. Like what to say, like for example, that we are having an smartwatch. With the help of that, we are calculating our blood pressure and our activities and our steps, that daily steps, that what we have we are going. So in that steps, that with the help of those steps, that we can easily we can connect. Okay, we can get the data, and those data can be used by the hospitals. Okay, so in such a way that it is very easy for the hospital or a doctor to analyze what kind of problem that the particular human being is facing. So they can collect the data and they are analyzing the data, and with the help of that data that they are giving the treatment. Okay, this is the thing that we are doing with the help of the internet. So it is a modern era where we are in the internet. So without internet, there will be no devices are there. So it will be very useful for the humans. So here, ability to transfer the data over the network without requiring human to human or human to computer interaction. That is nothing but that I said an example where refrigerator. So it's billions of devices are connected already. So we can see here. So power plug. So these are all the things. These are all the very good examples for the IoT systems in homes. So smoke detector, as we know that, and smart gateway, and then inlet switch where and power plug, where weather sensor, and then smart light, and depends upon the weather that the light will be switching on and off, and door sensor where we can place it the door sensor and the motion sensor. If there is anyone is crossing or anyone is coming, that will be sensed under the vibration sensor. So which these all will produce an data. Okay, which this all devices which produce the data. So those data, whatever the data that we are going to take, and we are going to make these data as a business. Like for example, if we are taking this data, and then that can be categorized into three types of data. One is structured data, unstructured data, and semi-structured data. So what type of data that we are getting, we are collecting? And we are having n number of data, that structured data, unstructured data, and semi-structured data. From what type of data that we are getting? So that will be the major part, and we need to analyze that data, and we need to do some operations, and we are getting the outcome for some businesses. So over here, that in olden days, in a traditional method where we are dealing with, we have dealt with structured data, where nowadays that everything will be as like we are focusing on unstructured data as well. So what is structured data and what is unstructured data? So here comes that will be structured data now, that it will can of there will be the schema or text data. So we can consider the text data will be a structured data where we are going to process those data, and we are producing an output. And if we are if we are going for unstructured data, it can be of audio, or it can be of video, or any type of data that can be belongs to like unstructured data. In some cases, that if we are going for semi-structured data, it can be of like a XML file or a JSON files. These are all the semi-structured data. So what type of data that we are focusing? So that will be very important over here. So where here the unstructured data plays a major role now. Because of that, there will be the big data is there. Okay, there will be the data science course is also there. I think we know that there will be the artificial intelligence and machine learning is developing on side, and then data science is also very booming, and then cloud is also very booming. So which is all are interrelated. So we need to know that which without that this will not happen. Like the data science where we are dealing with all the data, how we are segregating the data, how we are dealing the data, and this is the main thing. So how we are having artificial intelligence and machine learning where without human intervention, how the machines are working, how the machines are doing the task. Okay, without the continuous intervention of human. So how we are getting the output? Okay, so that plays a major role over here. And the capabilities. So over here, IoT is a dynamic global network infrastructure with self-configuring capabilities based on standard and interoperable communication protocol. Here there will be the what to say, there will be the self-configuring capabilities based on the standard and interoperability communication protocols, that there will be each and every device will have a protocols. So the protocols can be, it is nothing but a set of rules will be there. So for the communication rules can be set, and then the data can be collected with an intelligence interfaces. So to for the users to give the support. Okay. Over here, the characteristics of IoT, here that network connectivity internet and things, sensor devices and data information, communication data distribution, as well as intelligent smart analytic, automation decisions, and then ecosystem community. So here these are all the seven characteristics of IoT. So I would like to brief you that the seven characteristics over here. So here that we are connectivity is the most essential characteristics, where that the connected devices are interact seamlessly and without any intervention, that it should be there and to get a data. So things like any devices that can be connected or is designed to be connected. It includes sensor, actuator, household devices fitted with sensing materials. Over here, data. So the flow of information between the connected devices and the internet, and the data is because that the data should be given by the sensor, and it should be observed by the device, where it should be communicated through the internet through the user to the user. Okay, this flow should be in a proper way. So if it is there, so the data are lost, the accuracy of data is very high, then we can collect those data. Over here, the communication. For example, that communication, like devices connected to the internet or to each other and share the data to communicate. Okay, how? So it can be of like range of data, so it can be of short range or it can be of long range. So that can be also that should be monitored. Where intelligence, so over here intelligence refers to the sensing capabilities of the connected. So devices where we know that there will be like what to say, there will be the two devices are there, which is sensing devices are there. So the devices which is the sensor devices is sensing and producing the data, and then it is connected to the internet and it is giving the result. So whenever there will be the two devices, sensors are there. So one sensor is working and another sensor is not working. So how we are going to see that those data, those communications can be in a proper way, where we need to get those data communications as well. And for here action, over this outcome of action can be performed by the devices, automation of various manual activities. Okay, so here ecosystem, the environment, in the environment point of view, the goals, communities, and then the whole picture. So it should fit. So ecosystem, it should fit. The IoT environment should fit for the ecosystem. So let we will have a what to say, like we will have a discussion. We will have a self-assessment questions over here. So we will, I think, you all can able to view the questions over here. So we will have a discussion. Is which of the following are characteristics of IoT? As we have seen this now, anyone can answer. Is which of the following characteristics of IoT? One is A is connectivity, B ecosystem, and C is both A and B, and D is none of the above. What is the answer? Or otherwise, you can use the chat box so that you can give the answer using the chat box. Yes, C, yes, Vijaya, A. Any other answers? Okay, C is the correct answer, where we have seen the connectivity on the ecosystem. Okay. So over here, that both A and B is the right answer. And then we can go to the second assessment question, like which of the following are characteristics of IoT refers to sensing capabilities of IoT devices. So what is this? Sensing capabilities of IoT devices. What is the answer? Which of the following are characteristics of IoT refers to sensing capabilities of IoT devices? Yes, anyone can use your chat box and you can answer for this question. Yes. B is the correct answer where intelligence. So the characteristics of IoT refers to sensing capabilities of IoT devices is intelligence. And then you can see which of the following is an example of things in IoT. So what are the IoT things? Example. So kindly give me the answer for this. Yes. I think we have discussed the same these two things with you as an example during the session. So kindly give me the answer for this using your chat box. It is not like we are going to give any marks. So it is like whether you have understood or you have listened or which is useful for you. This session is whether useful for you. So we are going to know about it. For that reason that I am requesting you to do that. Over here that I will give you the answer, both A and B as the answer. So smart watches and smart refrigerators are there, which is an example of IoT. Where which of the predicted percentage increase in IoT demand by the year of 21? So I will let me give me an example. Like let me give my answer. So in during the year of 2025, that we are going to expect about 75.4 percentage. Okay, increase in IoT demand. So here next one, which of the following is the first step in IoT device life cycle where it can be of deploy? It's the first step of the IoT device. Okay, select the advantages of IoT devices. So it can be of like I will move to the answer like provide better automation and control and then reduce manual efforts. This is the uh, right answer. Where we can go to the IoT protocols over here. The IoT protocols helps the communication between the various IoT devices and the cloud-based server over the internet. So why we are using the cloud-based server? So we cannot imagine the size of the data. So because of that we are storing our data in the cloud. So wherever and whenever needed, the data from the cloud that we can retrieve. Okay, you are able to get. And these commands helps to IoT devices to collect or receive the data over the internet and also help the server to send commands to the devices. Over here, there will be the four layers are there. One is application layer, transport layer, network layer, and link layer. Where here there will be in the application layer, all the applications are connected. Where with the help of that, we are retrieving the data. So here, transport layer. I think you know that application layer, HTTP, everything HTTP like XMAP, XMP, and WebSockets and DDS, where these are all the applications layers protocols. Okay, hypertext transfer protocol, like where we are going for the transport layer that will be of two. One is TCP transmission control protocol and user datagram protocol. So this can be connected. So TCP, which is a connection oriented protocol, where UDP is a connectionless. And here the network layer, there will be two types of IPv4 and IPv6 and 6 low PAN. Is a PAN is nothing but a personal area network. So here these are the IP versions. So that which is connected with all the versions like IPv4 and IPv6. Over here there will be the link layer is there. So with the help of the Ethernet, so we are connecting and we are getting we are transferring our informations, our data. So we will move on to the machine learning. So here the concept about the machine learning is like what is the concept about the machine learning, like we are getting the we are having the data over here. And what is machine learning? So first of all that we need to know about what is machine learning. then only then we can move on to the supervised learning and the unsupervised learning. So it will be very easy, that it is very good thing that we need to know that. So here, machine learning is a type of artificial intelligence that enables the self learner from the data and then applies that learning without the need of human intervention. Without any human intervention, the process should be done and the data should be received. Like here, I would like to give me I would like to give you an example. Okay. So for example, there will be like what to say. If I am going to the supermarket, I would like to buy a bread over there. Okay. So if I am going to supermarket and I am going to buy a bread. So after I am buying bread, what I will do next? What I will take in the supermarket. So many of you, if I am going to buy a bread, the next what I would like to prefer to buy. Any idea? After bread, what I can take? I can buy. Any idea about that? So if if you are taking bread, na, that there will be the jam is your preference. Okay. So whenever that if you are going for any supermarket, if the bread is there, so if we can keep the jam near to the bread, na, it is like 10 or 10 or 15 human beings that they are coming to the supermarket and they are taking bread as well as gram. So it is training based upon the training and the testing method that we are going to get the output. Okay. Um, yes, if with the help of the training and the testing that we can decide that there will be the bread is there, so we can place the jam near to that. So with the help of like 100 users are coming, so 80 percentage of users that they are preferring bread along with jamna. So this prediction is nothing but machine learning. Like, okay, for example, like I would like to give me an example for deep learning. So we have observed, we have get 80 percentage of users that they are going for bread as well as jam. So what about the 20 percentage? So we need to look for that 20 percentage as well. Is that clear? So if we know that we need to analyze for the 20 percentage also how we are giving the output. Okay. So here the 20 percentage also be concentrated based upon the learning. So based upon the analysis. So how we are going to get that? For example, like if some person is not taking jamna, so that person can be of diabetic person. So we need to place here like the things that the diabetic persons can take, they can use or they can buy. So we are concentrating in the deep and we are getting the result for all the users and with the like accurate or for example we are giving the solutions for all the terms na, like that is nothing but where we are finding with the help of the deep learning. Okay. Here, the machine learning is considered as a subset of artificial intelligence. So mainly concerned with the development of algorithms that allows the computer to learn from the data and past experiences. Okay. So here, Arthur Samuel first introduced the term machine learning in 1959. Okay. So over here, artificial intelligence refers to the simulation of human intelligence in machines that are programmed to think like human and mimic their actions. Okay, so automatically learn from data, improve the performance by experience, and predicts things without being explicitly programmed. Okay, so I have given you an example like there will be the users are there to take jam and bread like that. So with the help of that, you can connect with that example, and if you are seeing this automatically learn the data and improve the performance from the experience and predict things without being explicitly programmed. So that is nothing but machine learning. So over here, there will be a number of applications are there. So you can able to see this. So online fraud detection. So online fraud detection is in like ATM card or any fraud detection. So virtual personal assistant and email spam. So it is categorizing. So how whether you have think about the your email like you are having a preferences like spam mail is coming separately, and then primary mail is coming separately, and then it is categorized by the categories way that you are receiving your mail. So whatever the mail which is important to you, that will be displayed in your inbox, primary mail. So the remaining mails will be in the in some other menu, where here there will be the self-driving cars are there. So product recommendations are there, and image recognition, as well as the traffic prediction is also there. Traffic prediction, as we know that with the help of GPS, so we are predicting the traffic in the city. So that is happening. Like automatic language translation, yes, of course, that we are dealing with automatic language translation as well. So whenever that, if you are seeing any YouTube video that the translation is there, so you can easily you can check that. And social media features and sentiment analysis and banking domain and video surveillance and search engine result refining. So these are all the applications of machine learning where this can be like we are going to achieve uh, result or based upon the prediction, based upon the analysis. Okay. Over here, that the types of machine learning that can be categorized into these three, where it can be of supervised, unsupervised, and semi-supervised learning. So as we know that there will be like you can be sub areas according to the key kinds of problems. It can be categorized. So here about the supervised learning. So over here that I would like to give tell you an example over here. So supervised is nothing but a labeled data, which is already labeled. Okay, for example, let me give you an example. Like if your child is there, so if your child is going to place the finger in the like what to say like in the fire, so you know that the fire will hurt or the fire will burn the finger. Okay, so you are directly insisting your child not to do that. Okay, so that is nothing but labeled. For example, if we are going for unsupervised learning, so it is nothing but an unlabeled data. Okay, unlabeled data. What is unlabeled data? So you does not have any idea about whether you are putting your finger in the fire, whether it will hurt you or not. While before you tell to your child that you need to place your finger, and you are checking whether this if you are placing your finger that it will hurt or not, like your fire will your finger will burn or not. So you are checking. So it is nothing but unlabeled data. So unlabeled data as well as unsupervised learning. Is that clear? So let me give you an example for supervised. One more example. Over here, there will be an apple and bananas are there. Okay. So the machine learning algorithm will do this. Will check for this apple and uh, banana. Okay. So after that, the model which is already feed by this is this shape or this color, and these are all the things that which will be fixed for this banana and red color. So the size is in a oval shape. So it is fixed for apple. So automatically, if you are giving any data of apple or banana, it will the output will be of prediction, which is already labeled. So it knows the machine learning knows that apple is the size of this one and color is this one, like that. So if it will match which all the features which is already have, and it will produce the result. Okay, so unseen, like this is nothing but a supervised learning. Okay, so over here, supervised, so working principle, working of supervised learning, determine the type of data set, what type of data set that you are, and collect the labeled training data. Okay, collect the labeled, whether your data should be in a labeled manner. Okay, split the training data set into training data set, test data set, validate data set. You need to, for example, if you are having 100 percentage of data, so 80 percentage of data that can be used for training your model. So remaining 20 percentage of data that you are going to use for your testing. Is that clear? So let me explain you clearly. Like for example, 1,000 apples are there, 500 apples are there, 1,000 bananas are there. Okay, for training, and then 10 like what a cherry is there. Okay, 10 or 100 cherry is there inside that. So you can fix that 500 apple, and you can 400 banana and 100 cherry is there. So you are training with 80 percentage, like 800 data should be trained randomly. Okay, so if it is trained na, so if you are placing apple and you are checking whether this is apple or not. So while validation, you should use the test data, that which is already you are having, already trained data that you are not going to use. Whatever the data that you are having in the test data that you are going to use with the for the validation. Okay, so if you are using the cherry, and if you are giving the input as cherry, and whether you are going to get any data for that, no, which is already feeded data is only for apple and banana. So that should be like what to say, very good example that I would like to say. Like we are going to, I'm having a dog, so the dog is going to catch the ball. Okay, or take the ball from one place to another place. So first I need to do is, so first I need to train the dog to catch the ball, to catch the ball in the sense like it should pick the ball with the help of dog's mouth. Okay, so automatically I'm training for 10 days, and while I'm playing any cricket or anything, like I'm testing my dog whether it is taking the ball back or not. So this is nothing but a training and testing data. Okay, so this, I think, I hope that you have understood what I have explained so far. Okay. Uh, Over here, there will be, in the supervised learning approach, there will be of two, like classification, and there will be of regression is there. Okay, so here there will be the classification in classification algorithm. So it is based on the predict category output labels and responses for the given input data. Okay, over here, which is an example, like we can see the example, practical example over here. Like we would like to know the difference between cupcakes and apples, or apples and bananas. Yes, of course, we have seen that. We already saw the, what to say, like example. Okay, over here, like this there will be n number of methods and algorithms are there. One is support vector machine and SVM. It can be a say that in short form, that we used to say that SVM, logistic regression, random forest, and decision tree. These are all the algorithms, classification algorithms. Is that clear? These are the classification algorithms. Okay, that we are going to use. Okay, so here there will be the regression algorithms are there. So while we are going to see that regression algorithm, we need to find out what we need to know about what is regression. Like the key objective of regression is based, task is predicted, predict task is to predict output labels. Okay, so the task is to predict the output labels for the given input data. Okay, so all regression problems are about predicting something. So how you are going to predict? Okay, how many degrees will be the shade tomorrow? So how many days are left before a crash occurs, or what your dream house will cost? So these are all the predictions. Okay, so this will be a regression. Okay, linear regression, non-linear regression, regression tree, polynomial regression, Bayesian linear regression. These are all the algorithms. Okay, regression algorithms. So quickly we will move on to the unsupervised learning algorithm. Okay, so here I would like to show you about unsupervised learning algorithm. It's a type of machine learning. As we know that it is an unlabeled data set. So I have given you an example for unlabeled data. What is unlabeled data set? How the unlabeled data sets are. Okay. So we need to finalize that. We need to label those data and we need to get the output. Okay. So over here, there will be no labels or a correct outputs are there. The task is to discover the data structure. For example, grouping similar items to form clusters. So there, here, unsupervised learning will form a cluster. So group of values or an items. Okay. So based upon like forming a group, like there will be like if we are going for any cricket that we will form a group, no. So we will make a team. So this group is for this team for my team, and that group is for opposite team. Like that, we are going to form a group, no. So we are forming a cluster. Okay, so reducing the data in the smaller number of important dimensions. The data visualizations can also be considered in the unsupervised learning. Over here, this will be of like what to say, category of input data is here. So you are going to label this data. Okay, unsupervised learning that you are going to label what is this you are going to do. And here working of unsupervised data. So we have taken the unlabeled input data, which is not categorized, and corresponding outputs are also not given. Okay. So this unlabeled data that we need to train the model, and then we need to find out the data, like k-means of clustering and decision tree, all the algorithms. So when it comes to types of supervised categorized into two, unsupervised learning, clustering, and another one is association. Okay, types of unsupervised learning, and another one is first one is that can be of two. One is clustering, and another one is association. Where we have already that we have seen that supervised learning. So we have seen that classification and regression. Okay, the types of supervised learnings are one is classification and another one is regression. Over here that we are seeing the types of unsupervised learning over here. So in that there will be the clustering and associations are the types. Okay. So when we are going with a clustering method, so there will be a number of algorithms. Like we need to form a grouping the objects into clusters. So that is nothing but a clustering. So why we are grouping that object? The similar objects are grouped. Okay. For and the similar objects are grouped from the dissimilar. Okay, dissimilar objects. So like what to say, like we are going to find out in a crowd that we are going to find out how we are going to find out a thief or a stolen guy. So how we are going to like 10 families are inside a one room, so that we need to find out one guy which is not belongs to 10 family. So how we are going to easily that we can ask all the families to form a circle. So automatically, the 10 families will form a circle, so that the remaining one guy will be, which is not, who is not belong to the 10 families, will be separated. By the way, that we can identify the thief. Okay, so for that reason, that we will use for like that the same thing, that the data which is not similar dissimilar, that will not be grouped. So similar data will be grouped. Okay, so this is the reason. Over here, that there will be the association. So association rule is an unsupervised learning method used to find the relationship between the variables in the large database. Okay. So over here, there will be the large databases. So before that, I would like to discuss about the clustering algorithms. K-means clustering, hierarchical clustering, fuzzy K-means, a mixture of Gaussian, probabilistic clustering, exclusive clustering, overlapping clusters. Okay, these are all the clustering algorithms are there. Okay, over here that I would like to give me an association where uh, relationship between the variables in the large data set. So there will be the large data set is there. So what is the relation? What is the relation between the variables? So I have given you an example. Like we can go already that we have seen an example, very good example. Like what to say? There will be bread with jam, so that is a relationship. So where any user can go into the supermarket that if you are taking like bread, na, that they will go for jam. So it is a way like how we are relates that we are forming the relationship between the items or the data or the variables. So X belongs to Y belongs to Z. So directly we can write association rule. Directly X belongs to Z. So we can say that. So this is the example. I think now only I'm going to as you can see the example as well. Bread or jam item. Okay. So suppose if you need blood, so you need jam also. So that is the association rule. Okay. Over over here that association algorithm, A prior algorithm and eclat algorithm and FP growth algorithm. These are all the association algorithms. Okay. Over here, there we are going to see about the semi-supervised learning. What is semi-supervised learning? Small amount of labeled data with large amount of unlabeled data. So that is nothing but whether it can be of it is not belongs to supervised learning or it not belongs to unsupervised learning also. So it is a semi-supervised. Okay, small amount of labeled data and large amount of unlabeled data. Okay, falls between the unsupervised learning and the supervised learning is nothing but a semi-supervised learning method. Okay, you can I think you can see with the help of the diagram. Okay, labeled data and then labeled and unlabeled data over here. So supervised learning, which is nothing but you are categorizing, semi-supervised learning. So you can see. Okay, D is a very you can see the D, right? Right, next one. So working of semi-supervised learning, training the model with small amount of labeled training data. So you are training the model with small amount of training the data. Okay, that we are having already. So as we discussed, like we are having already small amount of labeled data that we are going to train those data and use the unlabeled training data set to predict the output, which we have already know. Unlabeled data, that data can be used for testing. So it will be very easy that we can able to get the output with the help of input, like we have trained already with the label data. So we are having already the unlabeled data as well. So we are using for the testing with the with unlabeled data and we are getting the output. So that is the semi supervised working model. Over here there will be errors in machine learning. So there will be a two error like bias error and variance error. So you can see. So there will be the bias error, variance error, and noise. The three parts are there. So here the amount of model prediction differs from the target value compared to the training data is nothing but a bias. Bias is nothing but amount of model prediction. The amount of model prediction differs from target value. How it is different from the target value. So that is nothing but a bias. So bias error results from simplifying the assumption used in the model. So the target functions are easier to approximate. Okay. So bias can be introduced by the model selection. So one is low bias and another one is high bias. Suggest fewer assumption about the form of the target function. Suggest more assumption about the form of the target function. Is nothing but a higher bias. So you can see here that can be categorized into like you can see here the supervised machine algorithms that we have seen no. So that can be categorized into two. One is low bias example algorithms and another one is high bias. So low bias is SVM support vector machine and K nearest neighbor and decision tree. Where high biased are logistic regression, linear regression, and linear discriminant analysis. Over here, the variance. So if we are going for any variance, like the amount of estimated target function will change if the different training data is used. Okay, what is the variance? Different data are used now. What is the variance? So that the target function is estimated from the training data. How they are going to estimate the target function? Okay.
Yeah, I think sir's voice. Sir, can you hear
Uh,
me? Yeah,
yes, sir. Internet problem. Yeah, sir.
yeah,
Yes, sir. Yes, sir. Yes, sir.
yeah. Go ahead, go ahead.
Yes, sir. Here, yes, sir. Thank you. And then here there will be the target function is estimated from the training data. Okay, whatever that we have trained, that the with the help of that the target function is estimated. So variance indicates how much the estimate of the target function will alter. Okay, so how much the variance. So the small changes to estimate the target function will change in the training data set. So higher variance. So there will be the significant changes in the estimate the target function changes in the training data set. So how we are doing that? So there will be the low variance example as well as a high variance. So logistic regression, linear and linear discriminant are low variance. Low variance example with high bias and high variance example with low bias. Okay. So over here that we can able to see there will be with the help of this diagram that we can able to observe like underfitting problem and then overfitting problem. Okay. So there will be the underfitting problem and overfitting problems are there. So that whatever the data that we are like we are supposed to fit that we are supposed to like cluster or form a cluster. So there will be the overfitting and the underfitting problems will occur. So how we are removing that? How we are using? Sorry, what to say? Like how we are eliminating that? Okay, by any loss function. So it can be of loss of 0.5 or it can be of 1, 0 to 1, it can be of loss function. So what loss functions that we are using? So like we can able to say that with the dropout and without dropout, there will be the loss can be reduced. So with the dropout, there will be the loss function is 0.5 and without there will be no dropouts are there. So how we are eliminating the overfitting problem? So like we can use with and without dropout. Like you can check what to say. Like you can use Kaggle or GitHub to check the with and without dropout functions. Okay, in machine learning. Like over here, there will be the bias variance trade-off. So a total error can be calculated with the based upon the bias power 2 plus variance plus irreducible error. Okay, so this is the error, total error can be calculated. So overfitting problem, sir, sorry, like I will give you an example. Fitting ourselves in an oversized shirt. So that is nothing but overfitting problem. Okay. So a statistical model is overfitted when we train it with a lot of data. Okay, I think you can easily understand with the help of example fitting ourselves in an oversized dress. The size is very like our size is like 34 or 32. That we are using 40 size. So it is nothing but a overfitting problem. Okay, so that should be monitored, and it should be like regulated, and we need to uh, model the data which is not a overfitting. Okay, overfitting happens when the model learns the detail and noise in the training data to the extent that it negatively impacts the model performance on a new data. In a null set, overfitting high variance and low bias. During that time, the overfitting problem will occur. So here you can able to see here underfitting is nothing but which is not belongs to too simple to explain the variance. So appropriate fitting is nothing but this one. Okay. So like already which is grouped. Okay. Overfitting is nothing but which is everything which is mixed. Okay. Force fitting too good to be true. That is nothing but overfitting. So so good fit. So here the methods to achieve a good fits are resampling method and validation data set. These are all the two methods that we are going to use for resampling method and validation data set method. Okay. And I would like to discuss about steps to limit overfitting, increase the when there will be the overfitting problem is the in the data is occurs now. So we are going to check for increasing the training data, reduce the model complexity, early stopping during the training phase. So regularization and lasso regularization, these are all the regularization methods. Okay. So I think you know that we have I said you know like use dropout. So with the dropout and without dropout. So with and without dropout, which gives you an gives yeah exact example. So if the dropout values can be of like 0 to 1. So if I am giving a value of last value is 0.5 now, so it can be of middle 50% that I'm considering a loss. Okay. So over here there will be a number of supervised learning algorithms. So as we mentioned, as we seen over there. So what is linear regression and logistic regression, decision tree, random forest, support vector machine, and k nearest neighbors. So these are all the algorithms. So I think I hope like I I think you have an idea about what is supervised learning. So far that we have discussed about IoT and what is supervised learning and what is unsupervised learning and what are the algorithms that we are using for supervised and unsupervised, and also that we have come up with an what to say like uh, overfitting problem and then underfitting problem as well. So for overfitting problem, what are all the methods that we can do to reduce the overfitting, that also that we have discussed so far. I think if you are listening that you can learn many things. You can if you are observing that you know what is supervised and unsupervised, why we are going for a IoT, what is the importance of IoT. So everything that we have discussed so far. So I would like to go to supervised learning algorithm now. There will be linear regression. So used to predict the continuous value. Okay, such as the price of a house or a number of sales. Okay, so this is a very good example for linear regression. So when we are going for logistic regression, predict a categorical value, whether a customer will buy a product or not. Logistic. Okay, so decision. So it is like built a tree-like structure to represent the relationship between the input feature and the output variables. Okay, decision tree. So tree-like structure. This is nothing but a tree-like structure which relationship between the input feature and the output variable. That is the decision tree. Okay. So where random forest, if we are seeing the random forest, ensemble of decision tree. Okay. It is nothing but if it is more accurate than a single decision tree, but it also more complex. Okay. So when what for what reason, for what algorithm that we are choosing? So that is a major part. So, where what type of data and what type of result you are going to obtain. So, what type of algorithms I can use. So, finally, that you need to understood and then you need to know about the algorithms. Then only you can apply the algorithm. If you are not known about the algorithms, for what it is these algorithms are used, so how you are going to apply the algorithms for the particular data. So this is the main criteria where we are going to check. Okay. So over here there will be the data are there, like random forest. This algorithm is an support vector machine. So finds the hyperplane that best separates the data points into two classes. Okay, so support vector machines hyperplane best separates the data points in two classes. Whenever that your data that should be separated with two classes, now that you can go for support vector machine. So k nearest neighbors predicts the output for a new data point by finding the k most similar data points in the training set and then averaging their output. So for what type of data, how you are using. Okay, then we can go to the unsupervised learning algorithms. These are all the unsupervised learning algorithms which is already that we are having that and when and where that we are going to use that. Okay, that should be that we need to clearly that we need to finalize, and then you go for the data cleaning process. Okay, so over here that clustering is there. So we are going to form a cluster like customer segmentation, anomaly detection, image clustering, everything is there. Okay, so in the clustering, so dimensionality reduction in that reduces the number of dimensions in the data set. So whenever you are using dimensional reduction, that it will leads to reduces the number of dimensions. So association rule learning, as we know that very good example, like bread and jam, like anomaly detection, so which is used to detect the fraud detection and fault detection. Okay, and then we can see a principal component analysis finds the direction in the data that have the greatest variance. Okay, the dimensional reduction and the visualization. Over here, the independent component analysis. What is that? This is a denoising and blind source separation. So here there will be the reinforcement learning algorithm. So this is a agent like what is reinforcement? Na? That the agent learns to behave in an environment by the trial and error. If there is any any achievements, it will give a like what to say, like it will give a credit rewards. Or if there is any problem, anything error or anything problem, like it will give a penalty. So that is nothing but reinforcement learning. Okay, where q algorithms are there, that model free algorithm. So q values can be mapped and represented, and here there will be the stars algorithms where which represents the reward for taking a particular action. So there will be one thing like what to say. There will be one reward that we are going to give. So one action that we are going to give. What type of action that you are going to give? Whether it can be of reward or it can be a penalty. Okay, that can be decided with the help of this algorithm. So deep Q learning and then policy gradient methods. These are all the algorithms which is used. Okay, so here predictive maintenance and then fraud detection, as we know that asset tracking, these are all the algorithms which is used. I think you can use these algorithms. So from this is the main applications that where we are using our machine learning. Okay, predictive maintenance for fraud detection, asset tracking, these are all the areas where we are going to use our IoT, machine learning in IoT. Okay, so predict when equipment is likely to fail, whether there will be the sensor will be placed. Based upon that, you are going to predict whether your equipment is going to failure or not. So it shows an indicator that it gives an accurate result. So with the help of the result, that you can easily understand whether your device is going to be a failure or not. Okay. So the next one is fraud detection. The machine learning can be used to fraudulent transaction. So this can be done by the machine learning algorithms to identify the pattern. Okay, like for example, like what to say, there will be the credit card usage is there, user is there. So the credit card user is going to pay his credit bill, their credit bill. So if he is a defaulter, so we are not going to the like that can be categorized into a defaulter. Like so, any other credit card company will not offer credit card to the person who is not having a good transaction. Okay, so this can be detected. Okay, based upon the data set that which we are already having. So asset tracking. So the track the location and the moment of the asset. Okay, this can be done. And health monitoring. So monitor the health of the patient. So with the help of, I think we know that we are having a smartwatch. With the help of that, we can get all the details. Okay, health monitoring. So smart transportation. So here improve the traffic flow and reduce the congestion. So how we are going to reduce the traffic? So there will, if there is any traffic is there, so there will be the sensor will be placed. With the help of that sensor, we are going to identify that whether there is a traffic is there or not. So how we are going to monitor that? Okay, and how we are connecting with all the traffic signals and we are producing the result and for the smooth flow of traffic. Okay. So and environmental monitoring. So there will be like weather changes and air and water quality and other environmental factors can also be a very good that we are going to check. Okay, we are using the environmental monitoring and some other like challenges. What are the challenges while you are going to face? Okay, data quality, the quality of data. So how the data set what you are going to train, it should have a quality. So if you are not having a quality of data, so it means that your data you are not going to produce a accurate result. So the training should be more important where the training model, if you are doing the training model data should be a very accurate one. So if it is secured, your testing data and whatever you are obtaining during the validation will be achieved in a accurate manner. So data quality should be there, good quality that you are getting good outcome and data volume. So for example, if we are having a data of 500 data, okay. So we are training a 400 data and we are using 10 percentage of our data for testing. Okay. So we are using and we are testing, and then we are having in another example that we are having 1 lakh of data, and we are testing of which can be used for testing of training of 80,000 and 20,000 of data can be for tested. So which produce a accurate result. So whenever your data set is very high, so for training also that you will give more data, and for testing also you will use more data. So in that cases the data set is very high na, that you will achieve a accurate result. So the data volume should be a major part over here that you are going to observe, you are going to obtain a accurate. So computational resource, right? What is expensive to train and deploy? So the challenge for IoT applications have limited computational resources. The resources are very high. So whenever that, if we are, for example, that I would like to give you, like if if we need to predict the person who is having diabetics. So how you are going to predict the person that they would like they in future that they are going to be affected by diabetics. How you are going to predict? So the data set is necessary. For prediction, the data set is necessary. What the data set fields are there now? Like the blood pressure, okay, and then what is the current sugar level, and what is the BMI, body mass index. These should be calculated. So how you are going to get these data? So like real time data is very important in these cases to predict your prediction. Whatever that you are going to predict, the real data set is needed. So how many hospitals you go and you are going to get those data? So whether the hospitals will give the data as you as your request, no hospitals will give you as you request. What they will do now, so they will ask for any confirmation, or some hospital they will not going to reveal their patients detail. So they are their customer, the patients are their customers. So how come that they will reveal the patient's details? So how they are going to give that? So computational resources. What is the how we are going to get the data? So only very less of data are there. So how we are collecting the data? Real time data or what type of data that I'm going to collect? So the security plays a major role. So whatever the data that it is transferring from your devices to the internet, so it should not be hacked by, or it should not be like do any changes, any intruder. It should not be there. So that there will be security plays a major role. Okay, whenever there will be the network plays a major role, now the security is also a major problem. So the network is nothing but all the devices are connected in the internet. So any device can access any device. Yes or no? Like if I am going to access any one particular device. So how I am going to access some particular device? So n number of devices are there. So how I am going to manage my data? How I am going to store my data in a secured way? How I am using my data? So this is the major problem. Okay. So here do an online study, prepare a chart to describe the difference between supervised, unsupervised, and semi-supervised. Okay, do that. I hope you have understood this. Okay, what is supervised learning, semi-supervised, and unsupervised? So let me give me an example, only one example. So it takes 1 to 2 minutes, so that I will show. Like this is a vCal tool where we can use the data processing can be done, data cleaning. So you can give explore. Okay, this is a very easy tool. Like you can use for your validation purpose. Okay, so testing validation purpose. So I'm having a data set of iris data set. So you need to choose what type of data that you are having. Like it and we have CSV file. So if I'm having a CSV file. So I'm uploading that and I'm going to use this data. So while I'm going to use any classification algorithm, how you what classification algorithms I'm going to use. Okay, so over here that there will be classification and cluster algorithms are there. So what cluster algorithms I'm going to use. Okay, so uh, you can use the classification and cluster algorithms and you can start and you can with the help of that you can obtain the cluster formation with an accurate value. So you can see this with the help of like what to say like is any random or whatever the algorithms that we have seen. Those algorithms are there over here. So you can see here. Okay, you can obtain and also you can visualize the graph as well. So it is a very easy tool that you can use for like clustering and classifications. So this is a very easy tool that you can use and you can get the result in an easy manner. Okay, Vika. So I think I hope that if you are listening, that I have given you an examples as well, and uh, we have seen IoT as well as supervised, unsupervised learning, and then as well as Vika tool, how you are going to use your Vika tool. Okay, so this is a session where if you are listening, that I believe that you learn something by this session.
Participants want, if you want to speak something, if you want to ask something, sir is here right now. You can uh, put your queries here in the chat box. You can write in the chat box. Yes. Yes, Pratik, Vijaya, Gagandeep. Yeah. Sir has covered in length the algorithm, machine learning in basically IoT. Sir has given some hands-on tool also. And it's a great treat for us on this auspicious day, the Chandrayaan day. So technical content sir has underlined. Yeah, Pratik saying kind. Okay. Yeah, sir. Email is it possible? Pratik is looking for your
Yeah, sure,
email in chat box.
sure, sure, sure.
Yeah.
Yeah, I will share my email.
Yeah. So you can approach to sir with email also if you have any queries further. Yeah, sir has already given the email. So I hope this is a very much good treat on this day. Again, I appreciate the efforts sir has taken, and we find the time for us for our interaction. So once again, I am very much thankful to sir for your valuable inputs for our participants. Over to Sai.
Yes, sir.
Yeah.
So once again, a very formal thank you on behalf of IIT Pune chapter, Buds Engineering Academy and Civic Incubation Center. I really thank you, and we are all very grateful for your time and expertise and all the insights that you have shared with us today. So thank you so much, sir. We look forward for more such sessions.
Sure, madam. Sure, madam. Thank you, sir. Thank you, Arjun, sir, and thank you, madam, for giving me an opportunity to share my information to all the participants over here. That thank you once again. We will have a discussion in future as well. I am happy to share my information, sir.
Yeah. Thank you so much, sir. Thank you so much,
Thank
sir.
you, sir.
Yeah.
Thank you.
So now further we'll yeah. Thank you, sir. Just put the
Thank you,
camera
sir.
on or off. It is you, but don't end the meeting. Otherwise, everything will end. Okay, sir. Yeah.
Okay, sir. Okay, sir.
Okay. So now we'll proceed. Next half an hour is there for as per our schedule now. So we'll have a little discussion. One of the topic which we are trying to learn over here. So that is one of the topic we'll try to learn today, as time is a little less. But today we'll try to talk about the natural language processing in IoT application. Natural language processing in IoT application. I think this is one of the image for your suppose for example just now our prime minister spoken from Africa and to the world also. So he spoke in uh, something earlier in Hindi, later in English. But point here is the languages throughout the words are might be different. So here you can speak in one language and that will be automatically converted into another language. I think the language translation it's one of the greatest application over here. One of the language translation. So you can easily convert from French to German or any other language, English, Marathi, and all. That's what the natural language processing. We are going to talk about it little bit. Then uh, here you can see the what the algorithm used for the natural language processing and what's happening today in the in this particular topic. So here we have some research paper. So we'll try to see some research paper. So we'll get an idea what's happening in this particular topic today. Now, first of all, here just you can see on my screen right now. The natural language processing, you can call it as a NLP. In Internet of Things applications refer to the integration of NLP technique and technologies. I think you can understand there are two aspects. One is a technique and one is a technology. Like that, VLSI technique and VLSI design, like that. So technology is one part and the NLP technique is one part into IoT device and system to enable them to understand. So process and respond to the human language. Process and response to the human language. And here, one more sentence you can just see. IoT refers to the network of interconnected devices, sensors, and systems that can communicate and exchange data with each other over the internet. These devices can range from smartphone applications and wearable devices to industrial machinery and environmental sensors. NLP, on the other hand, involves the interaction between computers and human language. So that's what our topic, NLP. Basically, the interaction between the computers and the human language, enabling machines to understand, interpret, and generate human language. So here are some of the applications. So we are trying to see this NLP where it is used. Basically, one of the greatest application. That's what the NLP is used for, the language translation. So here the first application you can see for this NLP that we can see is voice controlled interface. This is one of the application for this NLP. One of the most common application of NLP in IoT device control devices like smart speakers, thermostats, and lights can be controlled using voice commands. NLP algorithms process the spoken language, extract commands, and trigger the appropriate actions on the IoT devices. That's what the first application of NLP in the IoT area. Then one of the common application we come across daily for the NLP is the virtual assistant. Virtual assistant. I think if you visit some website, then also automatically the virtual assistants will be there. You can have interaction with that virtual assistant. Now, IoT devices can incorporate virtual assistant that use NLP to understand and respond to user queries, and these assistants can provide information, set reminders, perform tasks, and based on user commands. So we can have a user commands and some particular task is being performed. Just like our Chandrayaan, they have heavily used artificial intelligence and the controlled. They have heavily used, but that's just with to higher end, and what we are talking about it just the basic background for that. So this is another application for this NLP in the IoT environment. Now the third one more application is a textual data analysis. Now in textual data analysis, NLP can be used to analyze the textual data from IoT devices. So I think this might be important. For example, industrial settings, NLP algorithms can process text data from sensors to identify anomalies or patterns that might indicate equipment failure or maintenance need. I think, for example, as I given earlier example, the SCADA systems or discrete systems, control systems. For example, generator remotely we are trying to control, and suppose there is some failure, or there would be failure, might be in terms of, suppose for example, the fuel, or in terms of temperature. So that's what it is called as a equipment failure, and it needs a maintenance. As the temperature of the generator increases, then there is a need to have a cooling arrangement. Of course, it might be automatically you can control, or some it might be manually. That's what the data received from the IoT sensor, and that is called as a textual data analysis. Now, moving further, the contextual and understanding. So NLP can help IoT devices understand and contest the user interactions, and this is crucial for devices to provide accurate and relevant responses. For instance, smart thermostat can adjust the temperature based on not only user explicit command but also implied requests such as make it warmer in here. For example, remotely we can issue the commands, and you can control the temperature of suppose through ACs and through the thermostat that you may call as a smart thermostats and all. So that's what the another application of natural language processing in IoT context. Now, moving to the further, there is a one more application that is called as a language translation. The NLP can employ to enable real-time language translation in IoT application and smart earbuds. I think people are nowadays very much fond of these earbuds. So smart earbuds could translate languages for users while they're communicating with others using different language. So that's what the another application of the NLP. Similarly, the sentiment analysis. So here IoT devices can use NLP to analyze text or speech to determine the sentiment or emotional state of the user. Emotion, I think emotion recognition system nowadays, one of the area is being popping. And this help tailor response and interactions accordingly. Also, earlier we have seen some the security and authenticity. So we have seen the difference, what exactly the security and what exactly the authenticity. So for security reasons and the authentication reason, NLP can play a major role in enhancing security in IoT application. As I think you can understand what the security we have seen earlier. And voice recognition, speech analysis can also be used user authentication and access control. So it might be just open the window or some close the window or move on, forward, back. That's what the speech commands. And nowadays, the biometric, the information we are using for Aadhaar, for example, the security reasons. Similarly, the nowadays the speech signatures is one of the area is getting popped. Similarly, there is this can be used in healthcare application. So in healthcare, specifically in medical industry or medical field, we can call the NLP-enabled IoT devices can assist remote healthcare monitoring. For example, ICU theater will be there or ICU system, and remotely you can use the NLP to communicate with the patient remotely. Patients can communicate their symptoms or health status through speech or text, and NLP algorithms can analyze this information to alert healthcare providers of any concerning changes. So that's what the one of the again area of NLP. I think if the list is very big, but these are the some of the applications we can try to understand what exactly the NLP is being used. Nowadays, one of the government's dream project that the smart cities is coming up. The last around 5 years ago, government has announced the smart cities projects, the 100 smart cities and all. So for the smart cities also, this is again one of the important the area where NLP can be used to process text data from social media, news source, and other platforms to gain insights into public sentiment or opinions and issues. And this information can be valuable for decision making in the smart city initiative. For example, they may take the people's sampled responses, and that data can be analyzed, and that data can be presented in front of the decision making authorities, especially in front of the governments, so that governments can plan the civic facilities or the infrastructure based on the public opinion or public view or public demand, where the NLP is techniques and technology combinedly used. Similarly, most of the companies nowadays, the customer support is very important for many companies. So the customer support, the NLP-powered chatbots and virtual assistant can provide customer support in various IoT applications from smartphone device to e-commerce platforms. Now, incorporating NLP into IoT application brings about natural and intuitive interactions between humans and machines. As we have seen earlier, the human and machine, we can interact, human-machine interaction. The HCI also we can call human, the computer interaction. Similarly, enhancing the user experience and expanding capability of the IoT devices. And to create simple program here, what we have seen the NLP application. So the algorithm for this particular NLP application, which we have listed above. So first of all, again, we have to go for the Python, and in the Python, you can first of all go for the pip install speech recognition. Pip install speech recognition. That's what the package we need to get it installed in our the environment, the Python environment. And once you have this package installed in your Python, then you have to import the speech recognition as a SR. So this, the library, the speech recognition library to develop the NLP, this library is also required. And then you have to make a dictionary of a speak recognizer function. So function is required here, the speak recognition. You see, there are important aspects. One is a speech recognition, and one is a speech, we can call it as a identification, or you can call it as a speech recognition. Again, there will be some different algorithms. Of course, convolution coding algorithm is also one of it. If time today may not be possible, but the incoming sections we'll try to see that some hands-on on NLP, because today it may not be feasible to because of the time. Anyway, but the package required here is a function, the speak recognizer function, and then you have to say the microphone function. So microphone a function we are using as a source, and you can say you can recognize. So that hands-ons we'll try to include in our coming sessions again shortly. But here I think you can understand what the library, and then once audio is being recorded, then we have to check the audio. Some X person is, this audio belongs to the person whose data is stored in the database. So for example, just like our banking transactions, we have to use our biometrics for our banking transaction. So similarly, if you want to operate your bank account, so nowadays one more other concept is getting popped off is the suppose you can by phone itself, we can call it as a phone banking. There you can see the speech signatures are already stored in the bank server, and real time the speech samples are being collected via remotely. Of course, there is a error rate, and error issue is a issue. So that's why as of now it may not be 100% popular, but as the recognizers are accuracy is getting increasing day by day. So through phone itself, the if speech samples are already stored in the server, bank server, then person can communicate to the bank. So that person's voice samples are being sampled and compared in the bank servers, so that the bank will permit us for the banking transaction. So, or it might be for some wherever highly secured area where we need access of secure area, where just like a biometric, the you can have a speech signatures, or you can have a speech samples to access the secure environment. Moving to the here, the we can have a recognizer, and you can have a audio with the Google function. So that audio and whatever we have spoken that will be printed. Whatever we have spoken, that will be printed. And if any error is there, if recognizer got some error, then that error will be printed over there. So for that purpose, here if you look for the steps basically for that particular recognizer, then you see, first of all, the import the speech recognition library, as we have seen. Then you have to define the main function. That's what the steps in our algorithm, that you have to define the steps, and then create the recognizer instant from the library that you have to create, and use context manager to open the microphone as a audio source, and then print prompt and listen to the audio input, and attempt to recognize the audio using the Google speech recognition, and print the recognized text. Appropriate error message will be printed, and then if you want to save it, then you can save this entire code as a .py file. You can store it again. Now you can open the terminal and the command prompt, but we'll see as here. Yeah. So you can see this is a small program. So we'll try to take it including the next consecutive sections. But what we have seen, this is a code for that, the algorithm which we have seen. Now, as time is again running, but quickly just we'll move to the actually this is a few of the research papers over here. So all this research paper, it may not be possible for us to cover, but what's happening in NLP, just I will try to give you the headline just for you. I will not be able to explain, but if you look for the business domain, then in business domain, if you look for the NLP algorithm, you can see here chatbots, which we have seen, smart voice recorders, you can see, and smart Google translator. I think in Google itself, you can translate any language to any language. And also some for business application, the FAQs are there for the business applications. So that is what the NLP is used in the business dimension. I hope it might be clear to you, the natural language processing, and it is used in the business dimension. And moving to the next, as time is not permitting for us, but the here are just have the example they have given, the aspects of NLP for modern business. Aspects of NLP in modern business. You know that nowadays daily you will find the so and so companies, they have removed the people, or the people lost the jobs. Some so and so company 19,000, so and so company 20,000, so and so company 10,000. So daily nowadays you will find some news that so and so big company or major player, they have reduced the number of jobs. So this is the one of the NLP, so which is also contributing reducing. So we need not to worry the NLP or the AI models, they are eating the jobs, but new jobs will get created. So we should not be fear that different technologies will take the jobs, as of course the jobs taken by these technologies, but new dimensions or new jobs will being created, or that what the hope or the opportunity. Similarly, here you can see this NLP, the modern business, you can use for the text recognition. So in the text recognition, you can see in the text recognition, the email, text messages, phone calls, audio, video, chatbots. So these are the few of the things. And in this algorithm, which we have seen algorithm there, one is a text tagging, name entity recognition, semantic and sentiment, or the natural language generation you can call. So this is a one of the analysis. So these are the analysis for that particular NLP. Now moving to the yeah. Actually, there is a is one of the paper again here. We'll go only for the conclusion, but here is again one natural language processing. One paper recently they have published this paper. I think this is in 2021 they have given. So in this paper, just we'll go for the conclusion for this particular paper. So in this conclusion, you can see here the happening here on this screen. Yeah. Yeah. So natural language processing. Yeah. Natural language processing is one of the hottest topic in the computer science right now, and companies are investing a lot of money in this fields science. All is attempting to grasp natural language processing and its applications in order to pursue a career in this field. Any company needs to incorporate it into their operations in some way. In this paper, actually they have given the NLP in this particular paper, but from this conclusion, you can see how much the important field the NLP is there. So that's what the paper indicates in the 2021. Now today is a 2023. Now one of the NLP major application is the, for example, the chatbots. So in the chatbots, I think many applications. So this is one of the again paper which is published here, some international journal, volume 2, the reference. So here, as per this paper, you can see the chatbots. If you look at in this particular example over here, so there is a IT cloud is there. Suppose here they have given the user. Yeah, this is a user, and this is a chatbot application, and this is chatbot channel, platform, and chat engine. So that we'll try to include in the next sessions coming, chat engine, and then it is connected to the IoT cloud. That's what the one of the framework available for our NLP. Now I think this is one of the NLP example. I think everyone is come across this particular example, how we can communicate with the chatbots. So chatbot is one of the example for the NLP. Now again, we'll try to see the conclusion. You see, NLP which controls the PC or other applications, appliances. In the computer lab, the user can interact with the system using either web application or chatbot through computer or handheld device, and can have a control over the PC in computer labs. Hence, using this system, it is now more convenient to control the PC or other applications in the lab. And that's what the you can control the PCs through the NLP. That's what the they are saying. Similarly, there is one more paper. This paper they have published in March 2022. This is 2023. So as per this paper again, here just we'll directly go to the conclusions, because our objective is to understand what's recently happening in this particular thing. So quickly you can see here the conclusion for this particular paper. I think protocol, this MQTT protocol earlier we have covered. So these are some of the protocol. Also the application program interface which we have seen. Also the NLP, or also the message queuing telemetry transact. That protocol we have also seen. But moving to the here you can see NLP is a part of AI, artificial intelligence, which uses techniques that are computational to understand it, observe, renew human natural speech. The IoT agent NLP, natural language processing, for use of voice chat feature and for its text chat system and dialogue flow. So basically, you can see the how NLP and AI is related to each other, and how it makes changes in the business or creation of the jobs. That what we have seen. as we are trying to close, the participants, if they have any queries quickly, they can put it in the chat box. Otherwise, we have to close the session. One or two queries, if they have any general queries also, we can have. Yes, anyone, participants, anyone have any queries, you can put it in the chat box. Okay, then I think we'll close this session here. Over to Sai.
Yes, so first of all, thank you all the participants for attending to this today's session. And on behalf of IIT Pune chapter, Birds Engineering Academy and Civic Incubation Center, we will end today's session and we'll meet tomorrow as usual.
Okay.
Yeah. So should I end the session? Meeting?
Okay.
Should I
Okay.
end it?
Yeah, go ahead.
Okay, sir. Okay.